Hello everyone. Today we are diving into the fascinating world of telescoping series. It is a powerful technique, and by the end of this video, you will have all the tools to simplify these series and tackle tricky problems with confidence. So let's start. Now, a telescoping series is a series in which each term can be represented as the difference of two consecutive terms of the series. Now, what I mean by consecutive terms is that if there is a function f of r, then the next term will be obtained by replacing r by r plus 1 everywhere. So it will be f of r plus 1. Now let's see it with an example that what happens if we write the terms in this way. So for example, we have this series. It is 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on up to 100 terms. So now what I'm doing here is I will write 1 as 2 minus 1, 2 as 3 minus 1, 3 as 4 minus 1 and so on. Then this series becomes 2 minus 1 into factorial 1 plus 3 minus 1 into factorial 2 plus 4 minus 1 into factorial 3 and so on. The last term will be 101 minus 1 into factorial 100. Now let me open this bracket, then this will become 2 into 1 factorial. So this will become 2 factorial. So this is 2 factorial minus 1 factorial plus. Similarly, this will become 3 factorial minus 2 factorial plus so on. And this will become 101 factorial minus 100 factorial. Now as you can see, the first term cancels the second term of the next part. Similarly, I will cancel all the terms, then some previous term will cancel this 100, and finally what's left is factorial 101 minus factorial 1. So as you can see, writing these values, this complete term as a difference of two consecutive terms. Now how they are consecutive? The function is factorial k and the next term is factorial k plus 1. So we have uh, broken these terms like that. Now writing these terms like this cancels out the complete series and only two terms are left. That is the answer. Now let's see some basic types of questions. So this is type 1, where we have product of consecutive terms of an AP in the denominator. The technique is to make the difference of first and the last term in the numerator. So let's see the first question. Here we have 1 into 2, 1 by 1 into 2 plus 1 by 2 into 3 and so on. So the method says that we have to create the difference of this in the numerator. So the difference is 1, which is already there, and in each term there will be a difference of 1 only. So we have to write 1 as 2 minus 1 here. Then here we will write 1 as 3 minus 2. Here as 4 minus 3 and so on. So this will become 2 minus 1 by 1 into 2 plus 3 minus 2 by 2 into 3 plus 4 minus 3 by 3 into 4 and so on up to the last term, which will be 1 by n into n plus 1. So we will write 1 as n plus 1 minus n. Now just separate them, and after separating we will cancel one term, so this will become 1 by 1 minus 1 by 2 plus this will become 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4 and so on till this is one term. So this will be 1 by n minus 1 by n plus 1. Now again, as you can see, we can cancel some terms. So the second term cancels the first term of the next part. Again, this will repeat and we will cancel till here. Now what is left is 1 minus 1 by n plus 1. So this is the answer. Now try solving this second question yourself, then we will solve it. So now let me solve it. So as you can see here, these have a difference of 3 in it, right? So what we can do is, to make the difference of 3 in the numerator, we will multiply and divide by 3. So we will write 1 by 3 into 3 by 1 into 4 plus 3 by 4 into 7 and so on till the end. Now again we will repeat the same. We will write 3 as 4 minus 1 and here as 7 minus 4, and we will cancel one term out. So this will become 1 by 3 into 4 minus 1 by 1 into 4 plus 7 minus 4 by 4 into 7 and so on. So this is equal to 1 by 3 into 1 by 1 minus 1 by 4 plus 1 by 4 minus 1 by 7 and so on up to the last term. So the last term will be this has a difference of 3 and this is a AP, so we can write it as 3R 3N, and when we put 1 we need 1 here, so it will be minus 3, sorry, minus 2, 3N minus 2, and the other term is 3N plus 2, sorry, 3N plus 1, yes, 3N plus 1. Now we will write the numerator as 3N plus 1 minus 3N minus 2. Now this will be equal to 1 by 3 into 1 minus 1 by 4 plus 1 by 4 minus 1 by 7 and so on till, let's break the last term also. This will be 1 by 3n minus 2 minus 1 by 3n plus 1. So this cancel this, and similarly these terms will cancel out, and finally we have 1 by 3 into 1 minus 1 by 3n plus 1. So this is the final answer. Now let's see the third question. So here I have already written it in the summation form. Now also let me tell you how to solve this series using the summation form and without writing the complete summation and cancelling terms. So here it is summation 1 by 3r minus 2 into 3r plus 1, and this is from r equal to 1 to n. Now just multiply it by 1 by 3 and into 3, and now again make the difference of them in the numerator and separate them out. So I am directly writing 1 by 3r minus 2 minus 1 by 3r plus 1 and 1 by 3 out, r equal to 1 to n. Now the trick is that you have to write give the upper limit to the term wise greater value. For example, here if we put r equal to r plus 1 in this function, we will get this. So this is the term wise greater value. So we will put n in this term and put 1 in the term wise lower value, which is this one. So we will get 1 by 3 into 1 by 3 minus 2 minus 1 by 3n plus 1. So this will be 1 by 3 into 1 minus 1 by 3n plus 1. So this is the same that we got here. So I hope you understood that the trick is to put to first break this into consecutive terms, then put the upper limit into the term-wise greater term and the lower limit into the term-wise lower value. Alright, now let's see this question and we will solve it directly. Now this is the first term, this is the last term. So the difference is 4. Now let's create 4 in the numerator. 1 by 4 and into 4. Now we will write this 4 as 2r plus 3 minus 2r minus 1. So this is equal to 1 by 4 summation 2r plus 3 minus 2r minus 1 divided by 2r minus 1 into 2r plus 1 into 2r plus 3. Then just separate them. So this will be 1 by 2r minus 1 into 2r plus 1 minus 1 by 2r plus 1 into 2r plus 3. Now as you can see, if we put r equal to r plus 1 in this term, so we will get this term. So this is the tr plus 1 if this is tr. So now let's just put the limits directly. So this n goes here and 1 goes here. So finally we get 1 by 4 into 1 by 2 minus 1 into 2 plus 1 minus 1 by 2n plus 1 into 2n plus 3. So this is equal to 1 by 4 into 1 by 3 minus this term. So this is the final answer. Now let's see the last question for this type. Try solving it yourself and then I will solve it. So now let me solve it. So this is equal to now here what we can see is the term first let's get the difference in the numerator, so that is equal to 2. So 1 by 2 into 2, then 1 by 2 summation 1 to n r plus 2 minus r divided by r into r plus 2. Now just separate them. 1 by 2 summation 1 to n 1 by r minus 1 by r plus 2. Now here we cannot just directly put these limits. As you can see, if the function is here 1 by r, so putting r equal to r plus 1 gives us this term, but it is not present here. But here it is r plus 2, so we cannot use it directly. So what we can do is we can just add and subtract r plus 1 here. So this will be equal to 1 by 2 summation 1 to n 1 by r and minus 1 by r plus 1 and plus 1 by r plus 1 minus 1 by r plus 2. Now treat this as one series, this as another series, and then we will just separate this summation on both of them. So this will be 1 by 2 into summation 1 by r minus 1 by r plus 1 1 to n plus summation 1 by r plus 1 minus 1 by r plus 2 1 to n. Now we can just put the limits. As you can see, these are consecutive terms and this is also consecutive terms. So put n here, 1 here, similarly n here and 1 here. Now you can solve it and get the answer. Now let's see type 2. So type 2 says that we will have product of consecutive terms in the numerator, and to solve them the method is to make the difference of term after the last term and before the first term. So let's see it with an example. So here we have 1 into 2 into 3 plus 2 into 3 into 4 and so on up to n terms. Now what will be the next term after this? In this series it will be 4, and what will be the previous term? It will be 0. Now here also it will be 5 and here it is 2. So what we need to, sorry, this will be 1. Now what we need to do is take the difference of these, which is 4 minus 0, 4. Here 5 minus 1, 4. So we will multiply and divide this difference. So let me do it. 1 by 4 into 4 into 1 into 2 into 3 plus 4 into 2 into 3 into 4 and so on. Now what is the benefit of writing 4 here is we will break 4 into 4 minus 0. Here we will break 4 as 5 minus 1 and so on. So this will become 1 by 4 into. So this is 4 minus 0, which is 4 into 1 into 2 into 3 minus 0 into 1 into 2 into 3 plus this will be 5 into 2 into 3 into 4 minus 1 into 2 into 3 into 4 and so on. Also the last term will be, as you can see here, it will be n into n plus 1 into n plus 2. So we will write it as we will the 4 will be written as n plus 3 minus n minus 1. So it will be written as n plus 3 into n plus 1 into n plus 2 minus n minus 1 into n into n plus 1 into n plus 2. Now again, as you can see, we can cancel the terms. That is, the first term cancels the second part, so the second term of the other part. So similarly we cancel all of them out, and finally what remains is uh, this value. So that is equal to 1 by 4, and this is 0 only. So 1 by 4 into n plus 3 n n plus 1 into n plus 2. Now this is the second question. Try solving it yourself, then I will solve it. So let's start. Now here also you can see these are consecutive terms. If you put r equal to r plus 1 in this, you will get this term. If you put r equal to r plus 1 in this term, you will get this. So these are consecutive terms. Now as per the method, just see the next term. It will be 2 into r plus 1 plus 3. So it will be 2r plus 5. And what will be the previous term of this? Put r equal to r minus 1. So it will be 2r minus 2 minus 1. So this will be 2r minus 3. Now what is the difference of these two terms? It is 1 by it is 8. So we will just multiply and divide by 8. So 1 by 8 summation 1 to n, and we will write 8 as 2r plus 5 minus 2r minus 3, and the rest terms remain here. Now we will just separate them out. So this will be 1 by 8, 1 to n, 2r plus 5 into all the three terms minus 2r minus 3 into all the three terms. Now this is if you put r equal to r plus 1 in this term, so you will get this. So just put n here and 1 in this term, and you will get the final answer. So till now we have seen some of the basic types of question that are in this telescoping type. But telescoping series is not just these types, it is about observation. You need to observe the term and break it into consecutive terms so that it can be solved. So now let's see some more questions, and they will be not of the direct type, but you have to observe and break them. So now let's see. This is the kth term of a series and we have to find the sum. Now to solve this, you must know the identity. that is k to the power 4 plus k square plus 1 equals k square plus k plus 1 into k square minus k plus 1. Now here you can observe that if you put k plus 1 in this term, you will get k plus 1 square minus k plus 1 plus 1. So this is equal to k square plus 2k plus 1 minus k minus 1 plus 1. So this cancels and this is equal to k square plus k plus 1. That is equal to this. So if you put k to k plus 1 in this expression, we get this expression. Thus this shows that if this is the kth term of some of the kth term of the expression, then this is k plus 1th term. So these are consecutive. Now let's break this. So this will be k upon k square plus k plus 1 into k square minus k plus 1. Now the difference is 2, so let's make it 2k, so let's make it 2k and 1 by 2. Now let's break it, so this will be, and also add the summation 1 by 2 summation 1 to n 1 upon k square minus k plus 1 minus 1 by k square plus k plus 1. Now just put this in the term-wise greater, which is this one, and this will be term-wise lower, and you will get the answer. Now this is the important part, that you that this identity is used very often, and you must remember this. Now let's see the next question. So this question came in IIT. Now this is the series 8 by 5 plus 16 by 65 and so on. So what you should do first is you should write this in summation form so that you can see it clearly, that how these terms are formed. So let's write summation. Now as you can see in the numerator, all terms are multiples of k. So let's write it as 8k. Now let's see how k is related to the denominator. Now here you can see these all are odd numbers, but if you remove 1, so this is 4 plus 1, this is 64 plus 1, this is 324 plus 1. Now all of these are multiples of 4. So this is 4 into 1 plus 1, 4 into 16 plus 1, 4 into 81 plus 1. Now how this relates to the numerator is that here we have 1, here we have 16. So this is 2 to the power 4. This is what, 3 to the power 4. So we can write it as 1 to the power 4. Now I hope you can see what we need to write in the denominator, that is 4k to the power 4 plus 1, and limits are from 1 to n. Right. Now let me just erase it. Now to solve this question, you must know the identity, that is 4k to the power 4 plus 1 equals 2k square plus 2k plus 1 into 2k square minus 2k plus 1. Right. Now these terms have a special property, that if you will observe and put k plus 1 in this expression, you will get 2 into k plus 1 square minus 2 into k plus 1 plus 1. Now let's open it. So this will be 2k to the power 4 plus 2 plus 4k minus 2k minus 2 plus 1. So this becomes, sorry, this is k square. So this becomes 2k square plus 2k and plus 1. So this is same as this. So what this means is that if you take this as a function, and so this is the kth term of that function, and this will be k plus 1th term. So what this means is that both of these values are consecutive. So we can exploit this property and just break this down. So this will be equal to 8k divided by also now let's see what is the difference. The difference is 4k, but we have 8k in numerator, so we can write it as 4k into 2 and the denominator as 2k square plus 2k plus 1 into 2k square minus 2k plus 1. Right, now let's break it. We will write 4k as this minus this and then split it. So it will be 2 summation 1 by 2k square minus 2k plus 1 minus 1 divided by 2k square plus 2k plus 1, 1 to n. Now just put the limits. N goes to the termwise greater, so n goes here and 1 goes here. Now you can find the answer. Now here also you must remember that this identity, and this is also very frequently used in such questions. And the second thing is that both of these values are consecutive. Similarly, as you saw above, here also this identity and both of these terms are identical. Sorry, consecutive. Right? Now let's see the next question. So try solving it yourself. Observe and then break them down. Then I will solve it. Now let's solve it. So first of all, let's write the general term. So the general term will be uh, let's say k divided by, now we have 1 in the numerator, then we have two terms in the denominator. So if we have k in the numerator, we will have k plus 1 terms in the denominator. And what will be the last term? So the last term is, as you can see here, it is 2k plus 1. So if you put 1 you get 3, if you put 2 you get 5, if you put 3 you get 7. So it will be 2k plus 1. Now we have all the odd numbers 1, 3, 5, 7, so on till 2k plus 1. So this is the kth term and we need some of these terms. So let's write it. This is summation 1 to n k divided by 1, 2, 3, sorry, 1, 3, 5, so on till 2k plus 1. Now you have to write k, you have to break k in such a way that after breaking they become consecutive terms. So what you can do is you can break k in such a way that in one term you cancel this out and in the another this remains. So if this get cancelled, then it will be 1, 3, 5 and so on till 2k minus 1. So in the denominator, one denominator will be this and other will be this. And if you see, if you put k plus 1, you will get this. So we can write k as 2k plus 1 minus 1 and divided by 2. So k equals this. If we put k like this, we can break it. So this is equal to summation 1 to n and 1 by 2. Here it is 2k plus 1 and minus 1 divided by 1, 3, 5, so on till 2k plus 1. So this is equal to 1 by 2 into summation 1 to n. Now in one term this get cancelled out, so this will be 1 by 1, 3, 5, so on till 2k minus 1 minus 1 by 1, 3, 5, so on till 2k plus 1. Now 1 goes in the term by smaller value and n goes in the greater one. So this becomes 1 by 2 into, now if you put 1 here, we need summation till only product till only 1. So this become 1 by 1 minus 1 by 1 3 5 so on till 2n plus 1. So this is the final answer. Now let's see some questions where uh, we have trigonometric terms. So to solve them you must know some identities. So these are some standard identities that you should know, and these are some observations that are useful to solve this uh, telescoping series, as we can break this product into some differences which we can exploit. So how we get this is, you can just open this sine a minus b identity and you will get this. Similarly, this is also same. Now let's see some questions based on this. So this is the first question. Now uh, as you can see, this is sec a, sec 2a plus sec 2a, sec 3a, and then so on up to n terms. Now first of all, let's write this is in cos, as we have some identities and properties that we can exploit. So this is 1 upon cos a cos 2a plus 1 upon cos 2a cos 3a, and so on up to n terms. And the last term will be 1 by cos na cos n plus 1a. Right, now in question in which you have cos or sine products in the denominator, you should try to create a sign of difference in the numerator. For example, here it should be sine a in the numerator, that is 2a minus a, and similarly in all of them, so that we can use this identity and break them into tan terms. So let's multiply and divide them by the difference, that is a in all of the cases. 1 by sine a, and this will become sine a sine a, and this also. Now we can write this a as the difference of these angles. So this is 1 by sine a into sine 2a minus a by cos terms plus sine 3a minus 2a and those terms, and so on. Now we can just break them easily. Now how to break them? We will break sine c minus d as tan c tan d, right, this complete term. So this will break as tan 2a minus tan a plus tan 3a minus tan 2a, and so on till tan n plus 1a minus tan na, and 1 by sine a. Now as you can see, again the terms cancel out, that is the first term cancel the second term of the second part. So this will cancel, and finally this will get cancelled. So what's left is tan n plus 1a minus tan a divided by sin a. So this is the answer. Right, now in the next question I have generalized this expression, as here we have common difference of a. So in the next question, here we have common difference of generalized d. Now let's solve this in summation form. So first write this in cos 1 to 100, 1 by cos a plus n minus 1 into d cos a plus nd. Now what is the difference we have? The differences of d. So we will create here sin d and 1 by sin d. Now d is constant here and n is the variable. Then we will write d as a plus nd minus a plus n minus 1 into d, right? Then just break them in tan values. 1 by sin d summation 1 to 100 tan of a plus nd minus tan a plus n minus 1 into d. Now again just do, what we do always is upper limit to the term wise greater term, which goes here, and this goes to the term wise lower value which is here. So what we get is 1 by sin d into tan a plus 100d minus tan a plus 1 will cancel out, this will become 0, so tan a. So this is the final answer. Now this is a similar question in cosec values. So let's first convert it into sine. So this will be 1 upon sine a plus n minus 1 into d and sine a plus nd. Now again, when you have sign products, we should create a sign difference in numerator. So the difference is this minus this, that is d. So we'll create sine d in numerator and 1 by sine d. Here also variable is n. Now this we can be written as a plus nd minus a plus n minus 1 into d, and then we will just break them in sine terms. Sorry, tan terms. So this is sine d summation 1 to 100 tan. Now let's see how to break it. So sorry, not in tan, here it will become cot, right? And cot also the d first, that is the negative part, and then you will get the c part, right? So let's see, this will be cot of the negative part first, that is a plus n minus 1 into d and minus cot a plus nd. Now 1 goes to this and 100 goes here, and we get 1 by sin d into this one will cancel and this will be cot a and minus cot of a plus 100d. So this is the answer. Now this is the next question. Try it yourself and then see the solution. So now let me solve it. Now again, as you know, in we have tan and cos here, but we have no such identity or such something that we can solve in tan. So let's just first convert it into sine and cos. So this will be sine 1 by sine sorry, cos 1 and cos 2 plus this is what, sine 2 by cos 2 cos 4 plus sine 4 by cos 4 cos 8 and so on till what is this, uh, sine 2 to the power n divided by cos 2 to the power n cos 2 to the power n plus 1. Now we by default in the question have a sine term in the numerator, and also if you observe their difference is present in the numerator, right? Here also if we see 2 to the power n plus 1 minus 2 to the power n is equal to 2 to the power n only. That is in the numerator. So we don't have to do anything, any multiplication or division in this. We can just directly break this. So this will be tan 2 minus tan 1 plus this will be tan 4 minus tan 2 and so on till tan 2 to the power n plus 1 minus tan 2 to the power n. Now just cancel the terms. First term cancel the second term. First term will cancel the second term, and finally this will be cancelled. And what we have is tan 2 to the power n plus 1 minus tan 1. So I hope you were able to solve this. Now the next question is this one. Now try to solve it yourself, and as a hint I would say you should use tan a minus b identity and find this product and try to solve it. Alright, so now let me solve it. So first of all, let's write it in the summation form. So this is summation tan na. Okay, let's change the variable. Tan k times a and tan k plus 1a, and limits are from 1 to n. Now the identity is tan a minus b equals to tan a minus tan b by 1 plus tan a tan b. Right, so now here you can see that we have this product that we need. So this product is equal to 1 plus tan a tan b equals to tan a minus tan b divided by tan of a minus b. Right, now we can take this one to the other side. So what we get is tan a tan b equals tan a minus tan b by tan a minus b in angle and plus 1, no, sorry, minus 1. Now just put this value here. So what we get is summation tan tan of k times a tan of, we have b, that is, sorry, this is a minus k plus 1 times a divided by tan of this minus this, that is minus a and minus 1. Now take this minus out and just change the signs. So we get a summation, and we will just separate the summation on 1 in this. So this will become tan k plus 1 times a minus tan ka divided by tan a and minus summation 1 to n 1. Now adding 1 n times will give us n only, and this is 1 to n. Just separate this out, and this is a constant, and this will go to the term while greater value and this to the lower value. Now you can solve it and get the answer. Now let's see the next question, which is sine cube 1 plus sine cube 3 by 3 plus sine cube 9 by 9 and so on up to infinity. So now try to solve it yourself, then we'll solve it. So now let's solve it. Now where you have seen sine cube, I hope you could remember that sine 3a equals 3 sine A minus 4 sine cube A. Now here you get sine cube. So you can get the value of sine cube from here and then put it there. So sine cube A equals 3 sine A minus sine 3A divided by 4. Right, now let's just put this value here. So what we get is, let's take 1 by 4 common out first, and then it will become 3 sine 1 minus sine 3 plus, this is what, 3 sine 3 minus sine 9 and divided by 3 plus 3 sine 9 minus sine 27 by 9, and so on up to infinity. So this becomes 1 by 4, 3 sine 1 minus sine 3 plus sine 3 minus sine 9 by 3 plus sine 9 by 3 minus sine 27 by 9, and so on up to infinity. So now here you can see that terms cancel out. The second term cancels the first term again, and this will go on up to infinity. So what's left is 3 sine 1 by 4. So this is the answer. Now let's see the next question, which is this one. Sine theta by cos 3 theta plus sine 3 theta by cos 9 theta and so on. So try to solve it yourself, then we will solve it. So now let's solve it. So now let's first write this in summation form. So that will be summation. Now we have power of 3's in the denominator, that is 1, power 2, power 3, and 1 less power in the numerator. So this will become sine 3 to the power k minus 1 theta by cos 3 to the power k theta, and k is from 1 to n. Now we don't have anything in any product in the denominator. So how to solve this? To solve this, what I'm thinking is to multiply by cos 3 to the power k minus 1 theta by cos 3 to the power k minus 1 theta. Now why I'm doing why I did this is, I want to use sine 2a is equal to 2 sine a cos a. I want to create this 2 so that I will write this 2 as 3 minus 1. Right, now as you practice you will be able to see these things. So now I need to multiply it and divide by 2. So this becomes 1 by 2 summation 1 to n, and this will be sine 2 into 3 to the power k minus 1 theta by cos 3 to the power k theta and cos 3 to the power k minus 1 theta. Now again, what we need in the numerator is a difference of these terms, which we can now easily make. So this is equal to 1 by 2 summation 1 to the power 1 to n sine. Now we will write this as 3 minus 1 and then just multiply them. So this will become sine 3 to the power k theta minus 3 to the power k minus 1 theta, and divided by cos and cos. Now we have created a difference in numerator and we have the denominator also. and now we can easily break it this in 10 terms. So this will be 1 by 2 summation 1 to n tan 3 to the power k theta minus tan 3 to the power k minus 1 theta, and now n goes here and 1 goes here. So now you can find the answer. So till now we have seen some basic algebraic and trigonometric series and learned how to solve them. Now these are two results that you should remember and are very handy in some questions. So that is, if you have sine series with angles in AP with first term as A, common difference D, and you have n terms, so that is equal to sine of number of terms into common difference by 2, right, and divided by common difference by 2 into sine of mean of first and last term. What do I mean by mean of first and last term? Is this plus this divided by 2, right? And similarly, if you have series in cos with same conditions, you can write this also as exactly same, just here we have cos instead of sine, right? Now let me give you intuition of its proof, then you can try it yourself. So what I to solve it, what we need to do is to somehow break this into some a plus d by 2 and a minus d by 2, right? This term, and this also we will get a plus d by 2 and a sorry, what we need is a, here it will be a plus d by 2 and minus d by 2, and here what we will have is a plus d by 2 and a plus 3d by 2, so that these terms cancel out. This will somehow cancel this term, this will somehow cancel the next term, and so on. So now to do that, what we will do is we will multiply sine d by 2 and divide by sine d by 2 to the complete series, and we will multiply 2 also. So now you can put these inside the bracket and use sine into sine equal to cos minus cos, then terms will cancel out and eventually you can get the result. Similarly you can do with this also. So now we have covered the basics, and now let's see some interesting questions. So just let me write it and then we'll come back. So I have written the questions. So this is the first question. Now here we have given Fn as the Fibonacci series, and these are the relations. Fn plus 1 equals Fn plus Fn minus 1. This is the Fibonacci series basically. Now you have to find these two values. So try it yourself and then we will solve it. So now let's solve it. I hope you tried it. So now what we can do with this expression is that we need to break this in consecutive terms somehow. So what we know is by this equation Fn equals Fn plus 1 minus Fn minus 1. Now let's put this here. So this will be summation Fn plus 1 minus Fn minus 1 divided by Fn minus 1 Fn plus 1 and 2 to infinite. Now this is equal to uh, let's just break it. So this will be summation 1 divided by f of n minus 1 minus 1 by Fn plus 1. Now these are not consecutive, so what is missing is f of n in between both of them. So we can add and subtract this. So this will be equal to summation 1 by f of n minus 1 minus 1 by fn plus 1 by fn minus 1 by f of n plus 1. Now this is one term and this is another. Now you can split the summation both of them. So this is n equal to 2 to infinite. Now for this part, infinite goes to this term and 2 goes here. And in this infinite n goes to this term and infinite goes here. Alright, so now you can get the answer. Also, putting infinite in the Fibonacci series gives us 0 only, right? Because this is increasing sequence and positive also. Now this, this is the second part. So now here what we have is 1 by f of n minus 1, f of n plus 1. But in the first part we saw that if we have fn in numerator we can easily break this. So let's multiply and divide by it. So it will be summation fn by fn minus 1 fn fn plus 1, right? Now let's just write fn as fn plus 1 minus fn minus 1, and now just break it. So this will be summation 1 by fn minus 1 fn minus 1 by fn fn plus 1. Now here as you can see, if you put n plus 1 here, so we will get fn fn plus 1. So these are consecutive terms, right? So we can just put the limits. Infinite goes here and 2 will go here. Now you can find the answer. Now this is the second question. So try it yourself, then we will solve it. So now let's solve it. Now in this question, first of all, we should write it as a summation so that we can see clearly what it is. So this is summation. In the numerator, we have odd terms 1, 3, 5, dot 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 till 2k, and if you put 1, we should get 1. So 2k minus 1 divided by even terms 2, 4, 6, and so on up to 2k. So if we put 1, we should get 4. So it's 2k plus 2. And uh, k is from 1 to n terms, right? Now to break this in questions where you have a product in numerator and product in denominator, generally what we can use is this trick, that you should multiply with the numerators, uh, like here this is 2k minus 1. So what will be its next term? It will be 2k plus 1, right? So now take the difference of both of them, this value and this value. So you will get 2k plus 2 minus 2k plus 1, and this is equal to 1 only. So you can just multiply it by this value. So this will be summation 1 to n 1 3 so on till 2k minus 1 into 2k plus 2 and minus 2k plus 1 divided by 2 4 6 and so on till 2k plus 2. Now multiply this complete value with this and break this. So now let's see what we get. Summation 1 to n 1 3 and so on 2k minus 1 into 2k plus 2 minus 1 3 so on till 2k minus 1 into 2k plus 1 divided by 2 4 6 till 2k plus 2, and this also divided by 2 4 6 so until 2k plus 2. Now the logic behind doing this is that if you now separate it, you can see in one term the denominator part can get cancelled one in the last value, and in the other nothing get cancelled, but in the numerator as you can see the next term is multiplied. So now if you see the previous term for this will be here dot 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 till 2k, right? Now if you put k plus 1 in this expression, you will get this, right? Here if you put k plus 1 you will get 2k plus 2, and here you will get 2k plus 1. So these are now consecutive terms. Now you can just put one in the upper and n in the upper and one in the lower one, right? So I hope you understood this. Now let's see the next question. So try it yourself. I hope you will be able to solve it. So now let's see the solution. Again, we write this in summation 1, 5, 9, and now these are AP terms with the common difference of 4. So on till 4k minus 3. And in the denominator what we have is 3, 7, and so on. Now here also it is in AP with common difference 4. So 4k, and we should get 3 if we put 1, so minus 1. Now again we use that same observation that we used in the last question. So that is find the next term for this, that will be 4k plus 1, and take the difference of both of them. So that will be 4k plus 1 minus 4k minus 1 equal to 2. So we need a 2 here. So we will multiply and divide by 2. Right? Now we will write 2 as this difference, that is 4k plus 1 minus 4k minus 1. Now we will separate them 1 by 2 summation 159 so on till 4k minus 3 into 4k plus 1 divided by 3 7 so on till 4k. Let me also write the previous term for this, that will be 4k minus 5 into 4k minus 1, and minus we have 1 5 9 and so on till 4k minus 3 into 4k minus 1 divided by 3 7 and so on till 4k minus 1. Now here as you can see this terms get cancelled, and what we are left with is this part. So if you put k equal to k plus 1 in this, you will get this complete expression. So the limits are from 1 to n. Now just put 1 here and n in the greater one, so you can find the answer, right? So I hope you understood how we can solve these types of question also. And now telescoping series is all about practice, so keep practicing. And if you want a video for practicing telescoping series, more questions if you want, you can just write it in the comment section. So bye bye and see you in the next video.